So, all right, acceleration notes. This is hopefully going to make sense, but it takes a really long time to start feeling super comfortable with what acceleration is. It's a weird concept. Some people catch on quickly, and some people take a long time, and sometimes you think you've caught on quickly, but then it sort of escapes you. So, blank tells you how something's position changes during a second. Blank tells you how something's velocity changes during 1 second. So one of these words I'm looking for is about change in position. So if you have, say, a person who is standing right here, and a little while later they're running this way, and they're over here. So they've gone from there to there, and maybe that's if I did this in time, this would be at 0 seconds. 1 second they're here, 2 seconds they're there, 3 seconds they're here, and 4 seconds they're there. So what's the thing that's telling us, hey, this person is going like this far every second? What's the word for that? Displacement is how far they've gone, period, but not how far they've gone each second. So this is describing, let me see. Yeah, let me do a different illustration of this. If this is a 0 meter mark, this is the 1 meter mark, this is the 2 meter mark. So in 1 second, somebody could go from here to here. Or in 1 second, they could go from there to there. What would they have to be doing differently if they were going to, yeah, so speed. So this is speed. And when I say how, you could also go like this. This is -1 meter. This is -2 meters. So you could go in 1 second from here to here, or in 1 second you could go from there to there. And these are all speeds, actually they're velocities. So if during a second you went from here to here, what would your average velocity be? If you went in 1 second, you went from there to there. 2 meters per second. If in 1 second's time you went from here to here, what would your velocity be? How many meters would you have gone in that second if you went from here to here? That'd be 1 meter per second. If in 1 second you went from here to there, what would your velocity be? -1 meter per second. And if you went from here to here in 1 second, then, so your displacement is -2 meters, the time is 1 second, that'd be -2 meters per second. So what I'm talking about here, when I'm saying how your position is changing, the position's either going 1 to the left, or 2 to the left, or 1 to the right, or 2 to the right. During 1 second, if we compare all those different kinds of movements in 1 second, that's telling us something's velocity. So if I say this person's velocity is -2 meters per second, where are they going to be after a second? They're going to be here. If I tell you that their velocity is +1 meter per second, where are they going to be in 1 more second? They're going to be there. So +1 meter per second means you add a meter every second. You're here, then you're here, then you're here every second. And +2 meters per second means you're here, 1 second later you're there, second later you're 4 meters. -2 means you start here, 1 second later you're here, and another second later you're at -4, then -6. Okay. So that's velocity. It's how far you go and in which direction during a certain amount of time. So what is the thing that tells you how much something's velocity changes in 1 second? That's acceleration. So the word velocity and the word acceleration, or the concepts, they're really very similar. Velocity, the formula is change in position over change in time. Acceleration, the formula is, you don't have to write it here, we're going to write it farther down. Change in what over change in time? What's changing with acceleration? Speed or velocity. So that's just going to be change in velocity over change in time. So this one is telling you how your position changes each second, and this one tells you how your velocity changes each second. So can you accelerate to the left or the right, or do you always have to accelerate one direction? Can I accelerate, like, can this person accelerate this way?
Yeah.
Yeah. Can they accelerate that way?
Yeah.
Yeah. So therefore, is acceleration a vector or a scalar? Does it have direction? So if it does, so if you accelerate this way, I could say your acceleration is +2. We'll worry about the units in a second. Or if you accelerate this way, I would say your acceleration is -2. So that means it's a vector or scalar. You need to know this. I'm quizzing you so you can get better at it. No, it's a vector. Anything that can have a negative in front of it or a positive is going to be a vector, because these are things that can be in different directions. So let's see. An example of not a vector, just a scalar, is speed, distance, and mass. Now this, I could take this over to the balance and put it on the electronic balance over there, and I think it'd probably have a mass of about 4 grams. Can this have a mass of 4 grams to the left or to the right or up or down? No. So mass is what? Vector or scalar? Scalar. It's just a scalar. Direction makes no sense with it. But acceleration, you can accelerate up or down or left or right, so it does make sense. Acceleration can happen in 2 different ways. So basically there are 2 ways to change your velocity. And you're probably thinking of 2 ways, but they're really the same way. So the thing that most people think of is you can speed up and you can do what? Slow down. But I'm saying those are pretty much the same. So this first way is all about changing speed. But I can accelerate without changing my speed. I love doing this. I'm going to get up in just a second, and I'm going to, like, let's say this is a 4x4 square on the floor. I'm going to demonstrate in this little grid how to have constant speed, but I'm still going to be accelerating. Okay, here, right in this whole area, I can do it. How do I do it? How do I have constant speed, first of all? What does that mean?
You have to get to a speed.
I get to a certain speed and I stay there. I don't go faster, I don't go slower. But right now, is my velocity changing? Nope. So how can I change my velocity without changing my speed?
You just gonna start timing around still to the time you move, like
Time I'm standing still to,
like the starting point. Like, you know what I mean? Like so you're like standing still to start, and then you like start your
so I
constant.
stand still and then
Start your constant. That's your.
I'm going constant speed. But between there, like, if you look at how fast I'm going now, and then I get up to a constant speed, if I were going to graph my velocity right then, if this is my velocity, I would, and this is time, I would say I did this. So this is when I was standing still, and then I started moving. So I had to speed up a little bit to get going, and then it was flat. But I want, maybe I'm going to put speed here. I want my speed to be like the same the whole time. This is a trick. So
You're just gonna start spinning around in a circle.
yes, not spinning though. I'm not going to spin. The key is it's a vector, and vectors have 2 parts to them. They have magnitude, which is the number, like 1 meter, 2 meters, but they also have direction, which is -1 or -2. So instead, so speed just tells you how fast. Velocity tells you 2 things: speed and what? Direction. So I'm going to write change direction, and then I'm going to go do it. I'm going to walk at a constant speed while changing directions. And I'll pretty much be doing what Branson said. Okay. So am I speeding up or slowing down?
No.
No, I'm trying not to. I probably am a little bit. But I'm going at pretty much a constant rate, but I'm definitely changing direction, and therefore I'm accelerating. So what I did was this. I'm going around and around and around in a circle like this. So if you're driving a car around a track and your speed never changes, your speedometer might be stuck on 60 miles per hour, but your velocity is definitely changing. This would be, we could call that negative 60 miles per hour, but by the time you get down here, you're going positive 60 miles per hour. So those are two ways to accelerate. You can accelerate by speeding up and slowing down, or you can change direction, or you can do both. Negative acceleration, I'm going to say instead of always, usually, what's the word for that we usually use? We usually call it reverse. Yeah, I guess you could. I'm just going to say deceleration. And in physics, it gets kind of confusing, but people say deceleration for slowing down and acceleration for speeding up. In physics, it's more complicated because you can accelerate to the left, you can accelerate to the right. We usually try to stay, I try to stay away from decelerate. The metric units are, I still haven't gotten to the formula. The formula is way down here. So if I'm going to write the units for velocity first. So velocity is meters per second. Does it make sense that velocity is meters per second? Think about what velocity tells us and think about if this is telling you that. So.
Most of the time meters per second, but it could be other distances.
Yeah, we use meters per second. It could be miles per hour. It could be, does anybody shoot Nerf darts or airsoft guns? Does anybody know what the unit they use is usually? Feet per second. Feet over seconds. If you're in Canada, what do you use then? Kilometers per hour. So it's always telling you how far and how fast and which direction, how far and which direction, and then a time down here. So this is distance over time, basically. So acceleration units, if this tells you how many meters you're moving every second, acceleration is going to tell you how many watts you're adding or subtracting every second. If I go faster and faster and faster, I'm not just adding the same number of meters every second, I'm adding what? So that's what velocity does. Velocity adds 1 meter and another meter and another meter. I'm doing 1 meter per second, or I'm trying to. And if I want to do 2 meters per second, 1, 2, like that. But acceleration is different. I start out and then I add, not meters, but I add what?
Is it velocity?
I'm adding velocity. What are the units for velocity? Yeah, so it's like this, but well, we don't write it like that because it's kind of a mess. So if you mathematically divide meters per second by seconds, you get meters per second squared, which is sort of a funny, I mean, this makes more sense than that, but this is how we write it because it's quicker. So velocity is how far you go every second, and acceleration is how much faster you get every second, or how much slower. All right. I'm thinking more about this. If Pam has a velocity of plus 6 meters per second, positive 6, that means she travels 6 meters for every second that ticks by. So it'd be what I was doing earlier, except I'd be taking 6 big steps every second. Another way to say this is for each passing second, Pam adds 6 meters to her position. Analogously, I like analogies. If Pam's acceleration is positive 6 meters per second, that's a different way of writing these units. This means for each passing second, and I'm going to set this up as a fill in the blank question. She adds blank to her blank. So if her acceleration is 6 meters per second, or we could write it as 6 meters per second squared, for every second that goes by, she's adding what to her what? What goes in either of these blanks? What's she adding on to? Instead of adding to her position, she's adding to her what? Her velocity. And if her velocity was 6 meters per second, she was adding 6 meters to her position. But with an acceleration of 6 meters per second, what's she adding to her velocity every second? How much speed? If this is her acceleration, how much speed is she adding every second? 6 meters per second. So that means if she starts out at time 0, if she's going 0 meters per second, how fast is she going after 1 second? 6 meters per second. And how fast is she going after 2 seconds? 12 meters per second. And then after 3 seconds, she's going 18 meters per second. So it's a little bit of a mind-twisting concept, but it's very much like what's happening with velocity. Okay, so velocity adds position each second. Acceleration adds what? Velocity. So velocity is about, it doesn't have to be adding, it could be subtracting. You can have a negative velocity. And acceleration doesn't have to be adding velocity, it could be subtracting, it could be negative too. So we've been doing things like this, where you walked away from the sensor and you might go like this. This is a graph of time is down here, and what was this over here? Do you remember? On all those graphs that we did. No, it wasn't velocity. It was distance. This was distance from the sensor. So this was basically position. I'm just going to put position. So the slope of this, if I make the slope steeper, what does that mean? What are you doing if the slope is steeper? Moving faster. If the slope is less steep, moving slower. So the slope is the velocity. So the velocity is the slope of a position versus time graph. It's the slope of this graph. And the reason is because this slope, the rise over run, is telling you how much your position is changing as time goes by. Acceleration is also the slope of a graph. It's not the slope of a position versus time graph. Guess what it's the slope of? Velocity versus time graph. So if you had a graph like this, like some of those other ones, velocity and time, and the velocity is going up and up and up and up, that means you're getting faster and faster and faster. Is there acceleration? Would this be acceleration, yes or no? Yeah. Would this be slower acceleration or faster acceleration? Faster, because it's a steeper slope. This would be slower acceleration. This would be no acceleration at all, same velocity the whole time. So if you can calculate the slope, then you've got the acceleration. If you calculate the slope of this one, you don't have acceleration, you have what? Slope. No, this is position versus time. This is the slope of this is velocity. The slope of this is acceleration. So now for the formula. Velocity describes a change in, I did this up above. Change in position over a time interval. Acceleration describes a change in velocity over a time interval. The average velocity formula, which we're most of the time just going to write with an A, because velocities are going to change in these problems, but if we ever have accelerations, they're going to be constant. It's delta V over delta T. So delta V stands for what? Change in velocity. This is how much your velocity changes in a certain amount of time. Change in velocity. And this is time, change in time. So if you have a big change in your velocity and a little change in time, you've got a big acceleration. If you don't change much in your velocity, or the time is really long, then you've got a small acceleration. We'll do a couple little practices and then a break, or quiz retake. So number one, suppose your velocity, this one I think you could just do in your head, but I'm going to use the formula. Suppose your velocity is 2 meters per second. 1 second later, your velocity is 6 meters per second. Don't blurt out the answer yet, but see if you can just in your head figure out what the average velocity, average acceleration would be. This one's pretty simple. And then I'll use the formula. You're going 2 meters per second. A second later, you're going 6 meters per second. Okay, what's your acceleration? 4 meters per second squared. So the formula for acceleration is change in velocity over change in time. And the change in velocity, it went from 2 to 6. So that's a change of 4. So we added 4. I'm going to write plus 4 meters per second. That's how much faster somebody got. And the amount of time was just 1 second. So 4 over 1 is 4. And meters per second. So let me do this. Meters per second divided by 1 second. Have you, in math, has it been a while since you've multiplied and divided fractions? So when you divide one fraction by another, what do you do? How do you do that? You multiply, but what do you do to it first? You flip one. You take the reciprocal of this. So this, I'm going to write 4 meters per second this way. This is sort of what's on the top. And I want to divide it by 1 second. But I need to flip that. So 1 second flipped is like this. 1 over 1 second. So when I multiply this, there's meters on top and seconds on bottom and seconds on bottom. So on the top, I get 4 times 1 is 4 meters. And then on the bottom, seconds times 1 second is just 1 second squared. Or this could be 4 meters per second squared. You don't have to worry about that. I'm not going to grill you over that. That's how the units work out. Okay, number 2. When your watch reads 8:01:32 a.m., your velocity is 6 meters per second. At 8:01:40 a.m. on the same day, your velocity is 2 meters per second. What's your average acceleration over the time period? See if you can do that. I'm going to give you a little time. This one's a little trickier. Some of you could do it without the formula, but I would just try the formula. And I'm going to do some other stuff over on the side. I'm going to write delta V, and I'm going to write delta T. And figure those out before I even get going. So V minus V0 and T minus T0. So So don't say the final answer yet, but help me out with this. What's the change in time?
8.
Yeah. So this is the final time, 8:01 and 40 seconds minus 8:01 and 32 seconds. So that's 8 seconds. And what's the change in velocity? Negative 4. So it's going from 6 to 2. So final is 2 minus 6 is negative 4 meters per second. Okay, so has anybody got the final answer? What's the acceleration? Yeah, Branston. Negative 1/2, yeah. So the change in velocity over change in time, and the change in velocity is negative 4 meters per second, and the change in time is 8 seconds. So A equals negative, you can call it negative 1/2 or negative 0.5. All right, so we'll do more in a little while.